Okay, so welcome. Welcome to Tammy and Mohammed, and to 7378204, and to Chanel and Chase and Katie Ann and Richard and Sierra and Elliot and Joy. And we'll probably get a few more. Thanks for coming. So this is the first regular webinar of the quarter. We did the orientation webinar, but that's real different. This webinar, we're talking about statistics. This is content oriented. So let me tell you the plan. I am going to go through at least parts of chapter 1 and chapter 2. So chapter 1 and 2 chapter 1 involves sampling and how to conduct a proper survey. Okay, it's not going to look very mathy at all. That's one thing about it. So it's how do you come up with who you want to survey if you want to survey, because that's a big deal, and you want to make sure you have as good results as possible so that you can learn about the world. And if you have bad results, then you haven't learned about the world. You've just tricked yourself, and you don't want to do that. So we're going to be looking at the different sampling techniques and some of the ideas on writing a survey question, and maybe even a little ethics. Then chapter 2, I know this is going to sound like the whole class, but chapter 2 is on statistics. So it turns out the statistics means all the numbers that you get from data. So we're going to be looking at the numbers, or things like the mean, which some of you think of as the average. We'll be looking at the standard deviation. We'll be looking at the median and the range. And there's a lot of different numbers you get. We're going to be looking at percentiles and quartiles. We're also going to be looking at how do you display your data. So how do you present it? If you want to make a presentation to your company or to the board of directors, or you want to publish a news article, what are some ideas on best methods of displaying your data so you haven't lost all your people and you have shown what you need to show so that people understand the data and understand the results of the data and what you can learn from the data. And we're going to have different charts to do that. A histogram is one of those. Most of you have seen histograms before from wherever. But we're also going to be looking at box plots and stem and leaf diagrams, and possibly others. Okay, I'll do as much as I can do. We only have an hour and a half or so, or hour and 15 minutes, and I try and do that. So that is the plan of the day. So again, very different than the orientation. Orientation is all about learning how to succeed in the class. This is about the content of the class. But I want to open it up before we start. If there are any questions, let me know. And you can pop it in the chat box, you can say it, whatever you want to do, and not just now, but throughout the whole webinar. If there's any questions, let me know. I'll always have one eye on the chat, okay, and one ear on your voices, depending on how you want to communicate. So are there any questions? Okay. So while you're thinking about questions, just to let you know, this is different than the orientation. The orientation is required to attend live, so actually, so are you going to display examples on the screen or mirroring on the desktop? I'm not exactly sure the difference between a screen and a desktop, so I'm not quite understand what you're asking, but I'm going to show examples on the screen. You're going to see examples. So this is very visual and audio. So I'll be talking, I'll be sharing my desktop. On your screen, you'll see it. Okay, so that's what you meant. Okay, so it's not are you doing the desktop or the screen? It's are you doing those? And the answer is yes. So I'll be displaying them a lot of stuff. Okay, so that's a yes. Okay, yeah, not a problem. This is again the time to ask questions and the time to not necessarily even know how to ask questions, but do your best, and that's all that matters. Again, there's low stakes. Low stakes is this particular webinar. All webinars are, in that there's no points given other than the secret word, which I'll give towards the end, And you can't go wrong in the secret word as long as you pay attention. And it's not like I like secretly give the secret word. I'll announce it in a big way. It'll be in color and boxed and all that. So you can't miss the secret word. And that's the only points for this whole thing. Any other questions before I jump to the ideas of chapter 1? Any other questions? Okay. Just a note, chapter 1 is probably the least mathy chapters of the entire course. So a lot of vocabulary, not any kind of calculations or anything like that. Chapter 2, we start calculating. So I'll do both today. And I want to also mention that since we only have an hour or so, I'm not covering every little detail. You're still responsible for reading the book and looking at the extra details that I didn't cover and watching the hour-long or the long lectures for chapters 1 and 2 so that you can get all the details. So what I do is highlight things. I also give you relevance. And I'm going to start out with a little bit of relevance. And I know not all of you are from Tahoe. Probably maybe not even 50%, but some of you are. So I'm going to give you an article, and maybe even you can guess, because I know some of you are from Tahoe. What is the biggest thing that is kind of the big thing politically that happened in the last 5 months or so that everyone was talking about? You actually had to vote on it. What was anyone from Tahoe know the big thing that happened? Yeah, Airbnb, Tahoe rentals, good. So I have an article on that, and we're going to be looking at, I'm going to use that as the idea. And actually, it's called Measure T. So what I'm going to do is, this is the Tahoe Daily Tribune, which is our local newspaper for those who aren't from Tahoe. And I like to bring up, live stuff. This is an article from January 8th, so you can't get more recent than that. And that's what I love about this class, is I can do this every week. There's no problem finding relevant stuff that's happening today. And that's definitely not true in any other math class I teach, just statistics. So let me just fill you in a tiny bit. Tahoe became a big town to do Airbnb, which means that if you have a house, you can rent it out, say, for a weekend to tourists and in a neighborhood, and there was a big debate whether that should be allowed or not. We had a ballot measure come up, and on that ballot measure, they said, should we ban it or should we not ban it, basically? Again, I'm simplifying things a little bit, but that's basically it. And we voted to ban it. Okay? I'm not going to tell you whether that was good or not. I'm just telling you what happened. So there's this article, and this is Ray Hoffman wrote a little article, City of South Lake Tahoe's Defense of Measure T, Still Undecided, and it's all about Measure T. Okay, and then towards the bottom, and this is what I want to look at today, there's a poll. Okay, and this is a typical thing a newspaper will do, is they'll have a little online poll, and the poll is, what do you think about the decision to try to stop Measure T with a lawsuit? And you have 3 choices. One is that it's a bad move, the voters have spoken. The other is a good move, Measure T must be stopped before it kills us all. And the third choice is don't care. Okay, so those of you who are from Tahoe, or even if you're not and you just want to have some fun, type in what you think. I'm not sure if it'll let me choose, but we'll see, in the chat box. And then we'll take a look. So how would you vote for this poll? Okay, voters have spoken, says Tammy. Anyone else? Measure T must be stopped. Okay, so now we're definitely split on this one. Bad move. Voters have spoken. Bad move. Okay, so I'm gonna see if it lets me. It didn't let me earlier in a different room. We'll see if it does now. It said I already voted. So let's try again. So I'm gonna vote. Yep, already voted. Okay, so I have to, unfortunately, click there. But what I want to do is look at the results of the poll, and we're going to talk about it and whether you can actually trust it or not. And here are the results. So what it said is, first, 50% said it's a bad move. 43% said it's a good move, and 77% said they don't even care. Okay, so a couple things to look at. The first is the survey question itself. So the survey question, I think this will be obvious, is the answer to the survey question involves words and not numbers. Do you all agree? So when you have a survey question whose answer involves words, we call the variable qualitative. Okay, and I'm putting in the chat box so that you can all see it. So that's called a qualitative survey question. Means, again, the answer are words. We're going to do a very special case of the qualitative survey question a lot in this class. It's the most common question that has words as answers, and that's the yes/no question. You'll see that a lot. This is not a yes/no question, but it's still, but both are qualitative. But the yes/no is kind of a special qualitative question. Okay, if it had numbers instead, see if anyone knows what's the opposite of the word qualitative. I bet some of you know this word. Yeah, quantitative. So if the answer is numerical, so that would be like on a scale of 1 to 10, 1 being a bad move, horrible, 10 being great move, best thing that ever happened, how would you rate it? That would be quantitative. Does that make sense? Because the answer would be, I rate this a 7. Okay, so that would be a quantitative survey question. For the quantitative survey questions, there's actually 2 types. There is what's called the discrete and the continuous. So again, today's a lot of vocabulary in chapter 1. So if you can list all the possible number answers, then we call it discrete. In terms of grammar, typically the grammar for the question will involve the words how many. And that would be like, how many times have you left the country in your lifetime? Right? And you could list all the possible answers. It could be a 0, it could be a 1, it could be a 2, it could all be up to 1,000 maybe, but you could list them all. Do you see that? Whereas if it's quantitative and not discrete, we call it continuous. And anyone know, instead of how many, what would the first couple words be? Back to the second one, the first one's still how. How the number of? Not quite, because that could be discrete. Because the number of could be, what's the number of times you've left the country? Okay, it's how much. So if you can ask the question as a how much question, that's going to be continuous. You can't list them all. So that'd be like, how much do you weigh? Right? And I weigh 168.35721465.3 pounds. Okay? Again, I could go on in terms of the number, and we call that a continuous. So most of the time, discrete will be only whole numbers and maybe a few extras. So I'm going to ask you a survey question. Let's see if you can type it in. Including yourself, how many siblings are in your family? Okay, this shouldn't be a hard question. Okay, you can't be 0 because you're including yourself. Just let you know. Yeah, 1's better. Okay. All right, just let you know, I'm going to type my answer. You'll probably all be surprised. Any guesses? My guess is no one will guess. No. 4.5. How can that happen? Yeah, I have a stepsister. I call her a half-sister. No, my cat's not a sibling. I love my cat, but she's not a sibling. But it was a good try. But I do have a stepsister, Laura. And so it's 4.5, but you could still list all the possible answers. I can't have 4.338 siblings. That wouldn't make any sense. But you could have a half sibling. So if you could list all the possible answers, we call it discrete. If you can't, if it's like an interval of the number line, including all the fractions and decimals in between, then it's continuous. So continuous are things like how much do you weigh, how much time did you spend in the shower this morning? That's continuous. Because that you could talk about the fractional time you spent. Does that make sense? Okay, so very important to know the different ways. Okay, so that was the first piece, is to understand the survey question and how to categorize the variable. Now comes the hard one. Okay, that's not, to decide whether it's discrete, continuous, or qualitative, that's not so hard. Here's the hard part. We notice if you add these up, 361 plus 317 is 678, plus 51 is what, 729. Okay, so they surveyed 729, I'm going to call it Tahoe people. Okay, we have, say, 20,000 or so people in town. So here's a question for you. 50% of the survey respondents said it's a bad move. Do you think that's a very good estimate of the population? Do you think it's a bad estimate? What do you think? Okay, Mohammed says bad. Okay, you're all saying bad. So now the big question is, why is it bad? So Tammy says not representative. Why is it not representative? That's a question that's more important. So why is it not representative? And we call that not random, by the way. Okay. Okay, only newspaper readers. So the question is, do you think newspaper readers are going to be more likely or less likely to say it was a bad move? And if they're not any more likely or less likely, there's no problem with it. Does that make sense? So only having certain people's okay, but only having certain people that are more likely to say bad move is not okay. Do you see that? So bias occurs if, because of who you asked, you're more likely to be on the high side or the low side of these percent numbers, 50% for example, then we say bias occurred. So for example, if they only surveyed people with type O positive blood, that's probably not biased at all. Because I don't think your blood type has absolutely anything to do with whether you think it was a good move or a bad move. Do you agree with that? Okay. So now the question is, do you think the people who are likely to answer this question are going to be more likely or less likely to say it's a bad move? Or do you think it doesn't make a difference and then it's representative and it's not biased? Okay, so Tammy and Chanel say more. Okay, and again, doesn't make a difference. Okay, and these are hard questions. Okay, but you definitely could be concerned about bias, but you should talk about what bias you think there might be. Any questions on that? Okay, now comes the harder question. Okay, we've definitely identified that there is no method to who they surveyed, and when there's no method, when it's just whatever is easy, and that's what they did, whoever happens to answer the survey who read this newspaper, we call it convenience sampling. And that's whatever's easiest. Okay, if you're going to publish, for example, in a educational journal, you know, like the Journal of Psychology or something, convenience sampling isn't a good idea. Okay, because it's not reliable. So now comes the hard part. And the hard part is, what might you do to have it better so that you can be more representative of the population of this town? What would you do specifically? Which 729 people would you ask? Okay, interview different workplaces. Okay, so you just go and you just go to 5 different workplaces and ask 719 people, 29 people in different workplaces. Subdivide the area by the city. Okay. Choose places at random. That's an interesting word, and I'm going to get to that. Okay. So ask the same number from each area. So subdivide the area, ask the same number from each area. Okay, so let me tell you some of your ideas and what we call them. We have statistical terminology for your ideas. So I'm going to start out with Tammy's idea, because that's the most formal, at least the way you wrote it. And someone else said it, but they just gave a word, and that was Tammy's word. And maybe you read the chapter or watched the video, which is great. That means that you feel smart, which is good. Both. That's why you know. So that's stratified sampling. So stratified sampling it's a multi-step process. Step one. Step one is identify the strata. Okay, personally, I don't think workplaces probably be the best stratified, would be the best strata, because places at work is probably not going to differentiate the population in terms of what they think about Measure T as much as some others. So you might, for example, stratify by political affiliation. Okay, there's a big difference in Republicans versus Democrats on whether they support banning the rentals. Okay, and again, if you're not from Tahoe, I don't expect you to necessarily understand why that matters. But I'm from here, and by the way, my own history, I've been here a long time, 23 years. And not only that, I often put this in the Two Truths, One Untruth. I was a politician for 9 years. So not only have I been here a long time, I really know the community. I wasn't an evil politician, if you think that's, all politicians are evil. I was a school board member, and I did everything I could to just help kids. Okay, so that was my thing. Okay, I didn't run for office the last time because I didn't want to be a career politician, and I believe in term limits. So I'm not a politician anymore, but I still care. And now I'm on the board for Boys and Girls Club. So I know the town really well, and political affiliation is probably the thing that differentiates people on whether they think Measure T is good or not. Okay? So in particular, what you would do is once you've identified the strata, so I'm going to give political affiliation as a strata. And let's keep it simple. Let's go Democrat, Republican, and other. Probably is the best way of doing it. Then what you do, step two. The next step is you need to find out the percentage of the population for each of the different strata. So you would go online and you would find out, well, what percentage of South Lake Tahoe is registered Democrat? What percentage of South Lake Tahoe is registered Republican? And what percentage of South Lake Tahoe is registered other or maybe not registered? And that you can pretty easily find that online. That's not that hard. You could probably just, ask Alexa and she'll tell you. Okay. Nowadays you can do that kind of stuff. Okay, so that's step two. Sometimes that's hard to do, sometimes it's easy. That's why I chose political affiliation, because that one's an easy one. Okay, step three. Step three is math, and the good news is it's easy math. Multiply the percents to find, by the sample size. Okay, so for example, we saw that the sample size, we want a sample size of what, 729. And let's suppose we went online and we found out that 56% are Democrat. So you take 0.56 times 719. You round that to the nearest whole number because we need to get the number of people you're surveying. And that's the number of Democrats in your quota. Does that make sense? Step four is survey. If you have any questions, let me know. So if it's only kinda, tell me what you need more information about. So survey that number, or those numbers of each of the strata. So then that's the hard part, because you actually have to go out and survey. Surveying takes a long time, by the way, especially if you have a sample size of 729. That could take days. And that's stratified sampling. Any questions on that? Any questions? So again, I'll be happy to, discuss more how it's all done. So I will let you know stratified sampling is the #1 sampling technique that's used in surveys. Okay, by far. So most polling agencies will use stratified sampling, and they tend to do multiple stratas. For this class, since it's elementary statistics, I'm okay for your project, for example, if you just do one. If you just pick, say, political affiliation or gender. But in the real world, they tend to pick a bunch of different types of categories and then make sure you have the quotas for all of the different categories. Okay, it's much more complicated. And there's some more stuff they do, which I'm not going to get into. Any questions on stratified sampling, which is, again, kind of the most common and probably the most important? Okay, so that's one way. And what's nice about stratified sampling is it removes bias that you're worried about. So if you're worried about a political affiliation bias, then this guarantees that you don't have a political affiliation bias. The bad thing about stratified sampling is that's all it does. So if you did political affiliation, that's all you did, and there's gender bias, well, then you got a problem because you got gender bias. Do you see? So you could do multiple stratas. Okay. Any questions on that? The other problem, and this is a huge problem, who remembers about 27 months ago or so? What was the big thing that happened about 27 months or so? Maybe 26 months ago? Yeah, the election. And some of you might remember, what did the news say the week before the election? What did it say? Okay, Hillary was winning, right? Hillary was going to win. Democrats were going to win. It was clear, right? What happened? Okay, and by the way, yeah, oops, but why oops is the question. What went wrong? And it's important to be able to analyze these things. So here's what went wrong. So I'm going to ask you. You could say yes or no. Type in yes if you have ever had someone ask you or call you to do a survey and you didn't answer. Say yes if that's happened to you. Okay, so everyone's going to say yes. That's just classic, right? So here's what happened. Okay, and again, I've analyzed this pretty deeply. That's what happened, is that all of the surveys were conducted by phone, just about every one of them. And what happens is that only a special kind of person will answer that phone call. Does that make sense? And that special kind of person who answers the phone call was much more likely to vote for Hillary, okay, than for Donald. So what happened is all the surveys, because they were done by telephone call, they got it wrong because they only got the people that answered the phone. Is that clear? That is a special kind of bias, and it's called voluntary response bias. It's a very difficult bias to get around. Okay, it's really tough. Let me give you one example of an organization that got around voluntary response bias, and it was a personal example. It was a good day for me. I did get a phone call, and they said, "We will give you $100 if you answer our survey." What do you think I did? Absolutely. Okay, and my guess is everyone they called, and I got the $100, by the way. Okay, and I answered the survey. It didn't take very long. It wasn't even a long survey. And what they did by doing that is they got rid of voluntary response bias because they got everyone to answer. And they have much better results. What is the problem with that? Let's say I had you do that for your project. Yeah, it's expensive. Okay, you would all run out of this class right away if I said everyone has to do a survey of, say, 35 people, and it's going to cost you $100 every time you ask someone. Yeah, you wouldn't do it. But again, if it's really important and you're an agency and you have to know, then you do it. And that's one way of getting rid of volunteer response bias. Any questions on that? Okay, I do want to mention that when you're doing statistics, it's not always a survey. So let me give you another, one of the big applications I've done as a consultant is Forest Service. Is that the primary way of getting around? Okay, so that's a good question, Sierra. There are actually two classic ways of getting around voluntary response bias. One is incentives. So financial incentives. Could be money, it could be a present, right? If they gave me a, I don't know, a free season pass or something, I might say yes to. But some kind of thing. There's one other way. Let's suppose we wanted to survey Lake Tahoe Community College students. Okay? And we wanted to survey them on, I don't know, some survey question. Something like, how likely is it that you'll take an online class? Okay, scale of 1 to 10 or something. And we didn't want to have voluntary response bias. So there is a way to do it, and it's cultural. And that's the only other way, basically, is cultural. Okay, so if you wanted to survey Lake Tahoe Community College students, that's the important thing. It doesn't matter what the question is. Okay, but your population is LTCC students. What you do is you have the professors ask the students. Because, yeah, it's authoritative. Because everyone would answer. If I hand out a survey to my students, you will answer. Does that sound right? It's a cultural thing, even though it's not like I'm going to beat you up or something if you don't answer, but you just do it. Okay? So there are other ways, but it's difficult. It works well in colleges and universities. It doesn't work well in general public, at least in our society, and I don't know enough about the whole world. Maybe we got some anthropology majors or sociology majors that could tell me that this country that would work. But it doesn't work in America, I'll tell you that for sure. Okay, China would work or not? Yeah, Japan would work better too. I've lived in Japan. That's the other place I've lived. Japan would work better than China, but not if I asked. It would have to be a Japanese to ask. Okay, and that is a weird cultural thing about Japan. I don't know about China, but if a Caucasian asks, they'll run away. It's a weird thing. Don't ask me why. They're afraid that they don't want to speak English because they're nervous about it. And then I speak Japanese, but they still think it's an English thing. So there could be sometimes there's a cultural way of making it happen. Okay, but let's suppose instead, we're not going to be surveying people. Let's suppose you're working for the Forest Service. And I'll just do something you'll all understand because it's easy. Let's suppose you wanted to find the average height of pine trees in the Sierra Nevada mountains. Okay, and by the way, Sierra Nevada is big. Okay, it goes all the way down near Bakersfield, all the way up past Tahoe. Okay, and there's a hell of a lot of pine trees in the Sierra Nevada mountains. Okay, I think you all agree with that. So could you, by the way, measure the height of every pine tree? Yeah, not a chance. Okay, you'd be dead by the time you finished. It would take so many centuries to do it. And then there'd be new pine trees. So you can't do it. So you have to do a survey. Okay, and it's not one where you're going to ask the pine tree, hey, how tall are you? There's no voluntary response issues. Do you agree with that? So the issue is more of logistical. Okay, because you could do something like stratified sampling, and that's pretty good, but typically what the Forest Service will do with cluster sampling. And what cluster sampling is, so let me type this one out because it's an important one. So cluster sampling means you divide the population into many clusters. Okay, that's the first thing you do. So in this case, you might do it by acres, for example. And you might take a map, which is easy to get a map, and you have, I don't know, 1 million or so acres. I have no idea how many acres there are, but there's a hell of a lot of acres in the Sierra Nevada mountains, right? And then what you do is you select a reasonable number of the clusters. Okay, that represent the population. Okay, so in this case, you might select an acre that is, yeah, so you probably want to be well spread out because you're probably not going to find a small location that has everything. Does that make sense? So you're going to probably have some down by the Sequoias, for example. You're going to probably have some that are southern facing, some are northern facing. Those who know about little biology in Tahoe, at least, I mean the Sierras, northern facing and southern facing is huge. Some that are flatter and have more water, some that has less water. Does that make sense? And a reasonable amount might be maybe 15 acres, something like that. Then you survey every individual in the selected clusters. So you go to those 15 acres and you measure all the trees in each of those acres. Well, except I said pine trees. So we're doing pine trees, so there's only one type. I guess you could do different styles of pine. You could do that. That's more like what you're interested in. I tried to keep it simple. Okay, so we're gonna pick a specific type of tree, and we're gonna find out how tall the trees for that type. Okay, you can get more detailed, but again, I can only do so much. Okay, so that's cluster sampling, and I want to do an example where it's not people, because I want to let you know not everything is people. And that's an example. Cluster sampling is done with people also. So for example, if you want to do Americans, it would be very hard to go to every city in America and survey one person in each city. Okay, that would be an extraordinarily difficult thing to do, logistically. So instead, you might pick, say, maybe 15 different cities in America that represent the population well, and maybe one street at each city or something like that. Okay, and that would work. For college students, what do you think the natural clusters are? Should be obvious, I'm hoping. Yeah, classes. So what you would do for college students is you would select classes, and you would make sure that you have a good representation of the classes. So, for example, our college here, I know Lake Tahoe Community College, we're about 35% online students. So if you were to do 15 classes, for example, then a third or so, which is 5 classes, would be online classes. And then the rest, the other 12 classes, 10 classes, would be face-to-face classes. And then with the face-to-face classes, you would probably want to make sure you have good selection, maybe an art class, maybe an English class, right? Maybe a kayaking class. So you'd make sure you have a good selection of classes that give a nice representation of the students at the college. And then you go and ask everyone in the class. Okay, have the professor do that. Does that make sense? And that would be a good way of preventing bias. It's not perfect, but it's a whole lot better than just picking your friends. Okay, because that would be horribly biased for whatever survey question you're going to ask. Is that clear? Okay, so then there is another technique. And I'm going to give this is especially done in manufacturing. Okay, so let's suppose that you have a business. I'll give you an example that I consulted for a few years ago. It was a former student, actually, who got a business. It's not that exciting, but he made towels for hotels. And he wanted to show that his towels were better than the ones made in China. So I helped him identify the towels to go and test to see which ones could go through more washings before they became ratted or whatever. Again, I'm not a towel expert, but I helped him with this. So he has, I mean, it's a big plant. It's in Vegas, actually. And he makes thousands and thousands of towels all the time. So what we did is he wanted a sample of, I think it was 200 towels. And let's suppose he makes 50,000 towels. Well, if you take 50,000 and divide by 200, what is that? 250. Okay, you can put in your calculator, trust me. So what we did is every 250th towel that came off his assembly line got pulled and put into the bin, and those are the ones that were tested. Does that make sense? And that's also unbiased. And the good thing about that is one of the things that kept the bias of is there are different people working on the assembly line. So that way, that bias is gone. It is completely unbiased. So what we did is we tested those towels. That is called systematic sampling. And that is select every nth in the population. That can only be done if you can actually order everything and get to them. So good luck doing it for all Americans. Get a list of all Americans, put them in order. Never going to happen. Does that make sense? But it works really well in manufacturing and some other things too. Okay. It'd be very hard to do in the forest, for example, because there isn't a natural ordering of trees in the forest. So you're not going to be able to do systematic, but it does work. It has its place and it is used. Now I'm going to do the last one. Here's the bad news. Yeah, every nth. So that again, every 250th in this example that I gave you. So you choose your n, so you end up with the sample size you want. If you take the population size, divide it by the sample size, that's your n. Okay. The next one is the very best possible sampling technique you can ever do. You want to hear the horrible news? It's almost always impossible. Isn't that the worst? The very best thing you can do, you can't do. And that is, well, Ask Everyone is not sampling, actually. Ask Everyone is conducting a census, and that's not a sample, that's a census. And that is the best, and you can't do that, but it's not sampling. Okay. The only time you could do a census, for example, if you wanted to find out the percentage of Americans that voted for Trump, we could do that because the census, we know all the voters. They counted them. Okay. But before the election, good luck. There's no way you're going to find out every American's preference. So usually you can't do a census. So given that you're doing a sample, the very best thing you can do is random sampling. So what random sampling means is that the probability of any individual getting selected to be part of the study is equal to the probability of any other individual of getting selected. So I'm gonna give you a little math here. P of X equals P of Y for every X and Y. Okay. So X and Y could be people. So the probability of you getting selected is the same as the probability of your neighbor getting selected, okay, and anyone else getting selected. All right, I'm gonna do something that I always do, and it always comes out the same. We'll see if you can do it. I want you to do me a favor. In your head, pick a random number from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. And write it down, or at least put it in your head and don't change it. Got it? That should take 1 second. Got it? Okay, put it in the chat box. Okay. All right, just to let you know, you think you picked a random number, but you didn't. Do we have any psychology majors here? Okay, Joy and Richard. So why didn't you pick a random number? It's more psychology than sociology, actually. Okay, we don't have the ability to do it, turns out. Nobody ever picks 10. Ever. And I've been doing this for a lot of years. 10 is never picked. So if it was random, 10 should be picked 1/10 of the time, right? But it's not picked. Okay? So you don't know how to pick a random number. Okay? One is very rare also. Now, if you watch the video, you're cheating because then you pick the video's number. Okay? But the point is we don't know how to do it. But who does know how to do it? Give me the name of the lady. Not seeing it? Alexa. You heard of her? Siri. Yeah, that's another one. Okay, actually in my house it's neither. It's Hey Google. Yeah, Cortana. So that's how you get a random number. You don't write down what you think is random. You ask a computer. Okay? And if you don't use any more of that's okay, then you type in Google and you type in, give me a random number from 1 to 10, and it really will give you a random number. I'm not going to get into the serious math. There's serious math on how it does it. I'm not going to do that. Okay? So random is very difficult to do. The only way to do it is to get a list of everybody in the population. Okay? And imagine doing that for all Americans. You can't get that list. Imagine doing it for every tree in the Sierra Nevadas. Good luck. You can't list them all. And then let a computer select random numbers to get your sample size, and then go and you collect the data from those selected individuals. That's the only way to do random selection. Okay? It can't be done with very large populations. You're never going to do it. So here's a warning. If I see the word random anywhere in your projects, in your discussion posts, or anything, or your tests, and you don't explain how you did random, I will take off points because I won't believe you did random, because random's impossible in most cases. Yeah, Gallup lies. What they do is they use random number generators. But as I mentioned, what happens when they call people? What did you all do? You hang up. So it's not random. Do you see that? They start with random numbers, but they don't end up with a random sample. Do you see how that works? And by the way, this is going to sound really weird. My second job ever in life, I was 10 years old, was calling people for a survey company. Nothing to do with knowing I was going to be a statistics instructor. It's a weird thing. And nowadays, that company goes to jail for having a 10-year-old work. But we were poor. I needed the money. You know, our family needed the money. It was different in those days. So I actually know how things work firsthand. Okay, my first job was paper boy, the paper delivery boy when they used to have newspapers. But I actually worked for this survey company, which is like really coincidental. Okay, Carroll Davis Market Research it was called. And we did random phone calls, random phone numbers, but a lot of people did hang up on me when I was 10. And they didn't know I was 10, by the way. Okay, so anyway, those are the different techniques of sampling. And again, you want to pick the one that can work for you and has the most representative study. Any questions on that? I want to give you one more before I go to chapter 2. We're going to do chapter 1 a little more than chapter 2. Chapter 2 is more calculational. And that is, let's suppose I'll give you an example. When I was a college student, I got I read the little article, and I was having a bad day, and you'll understand what I mean in a moment. It said, if you have the runs, run to the hospital and be part of the study that we're doing. Okay? So what's a good sample size? We'll get into that later. We're going to do sample size analysis, and we're going to do that in chapter 7 and 8. So it's not the percentage it turns out. That doesn't matter. What matters is what kind of survey you're doing, and is it qualitative or quantitative? And it's a little more detail, and we'll get to that another day, I promise. So sorry about that. Okay, so I got that article, and I ran to the hospital. I was poor. I needed the money. And they gave the doctor, I was in the study, the doctor gave me medicine, I took it, and I didn't get better. 2 days later, I had to go back for the second analysis. And the doctor said, how you doing? I said, not well. And then he confessed. And what he told me is that I took a placebo. And a placebo in this case meant I thought it was medication, but it wasn't. And that's called a control study. And what they did in this case was called a randomized control study. And what that means is, let's say they had 100 people that volunteered. Okay, I don't know what their sample size was for this one. It was just me. I was not the researcher. I was the guy with the medical problems, let's call it that. So what they do is they can split the group in 50-50. They give everyone a number, and they have a computer pick 50 of them to be the control, and the other 50 are the treatment group that gets the real medicine. The people in the study don't know whether they're control or treatment. Okay, that's called a blind study. That's a blind control study. Okay, only with control studies can you end up with a cause and effect relationship. If you don't do a control study, you can't say that this caused that. If you do a control study, you can. Okay? It turned out they did a double-blind study, which means the doctor didn't know which was the real medicine and which was not the real medicine. The doctor just wrote down the serial number of what was on the bottle, and the researcher in the background knew what that serial number meant, and the doctor didn't. Okay, the bottles all looked the same, they were just serial numbers. And that was what's called a double-blind study, which means neither the patient nor the doctor knows. And it's a control study, which means you can actually establish a cause and effect relationship, which is real important with medicine, because you want to be able to show that the medicine is causing someone to get better. Does that make sense to everyone? If you just do a survey, you're not going to get cause and effect. Any questions on that? Sometimes you can't do a control study. So for example, there was a study done where they looked to see whether children who were beaten by their parents as children grew up to beat their children when they grew up and had children. Okay, why can't you do a control study on that? What's the problem? Yeah, it's illegal, and I'm going to say even more, and hopefully you agree, unethical. Hopefully you agree that ethics are even more important than the law. Because the only way to do it would you'd have to split the volunteers up, and you would have to go, okay, these 50 parents, you go and say, you need to beat your child every day. Can you imagine doing that? Okay, you can't do a control study. Sometimes you'll never get that kind of cause and effect. Can't do a placebo. You definitely can't do a placebo study because the kid is going to know if they got hit or not. Do you see that? You can't placebo a hit. Okay, so there are issues. So I want to let you know that just because I said this is a study and this is a statistical technique does not mean you can always do it. Okay, you do your best and always be ethical. Okay, any questions on that? Okay, yeah, vaccines is one you can't do a placebo study on. That'd be bad. There's some they do, and I was like shocked. So brain surgery, they do placebo studies on that. Yeah, I was like shocked. I was watching a UC San Diego lecture, and they did that. So all for Alzheimer's. And they literally opened up people's skulls and didn't change them. Yeah, for the placebos. Yeah, yeah, it seems wrong, but this was recent. So you can for certain things. I was shocked. Again, I'm a statistician. I'm not, I think I watched it a year ago, the lecture. So I'm a statistician. I am not a doctor. Okay, so, and I'm not a lawyer or anything like that. So don't ask me why they're allowed to do it. I don't know. But I did watch the lecture. Okay, so anyway, those are some things to talk about. The next thing I want to do is I want to do statistics. That's chapter 2. So I want to share my desktop for this one. And I want to show you the spreadsheet that I created. And you're welcome to use this. It's specifically created for the project, so I suggest you do it. So let me go and share my desktop. And I think I have to, I think I'm on it, actually. I'm already sharing. So do you all see, you should all see Statistics by Larry Green? Okay, so you must do your projects using a spreadsheet. In fact, I just had someone come to my office today saying they're going to UNR. Is this class going to count? UNR requires spreadsheet. If I don't use a spreadsheet, they don't accept it. And then they would have to retake the class. So that's one of the reasons. Also, it's the way people do things. So this is my spreadsheet program. For you all, the first thing you're going to have to do is go to File. And then you have to go to Make a Copy, give it a name, and hit OK. I'm going to hit Cancel because I don't need another copy. But if you don't do that, then you're not going to be able to type in anything in the spreadsheet. This is a Google Sheet, and I can't let you have the true access, or you're all going to be fighting over what you're typing in. Okay, so in your group, you're going to, for your project, you're going to be using a spreadsheet. Okay, by the way, every week I'm going to tell you a little bit about the project. So the first thing we're going to do is I'm going to erase, and you just highlight and hit the backspace. And that erases all the stuff that was in there for the sample. Now, let's do a survey. Okay, and I've already asked you one question that was qualitative. I want to do a quantitative question, but I'm going to do kind of a similar one. In your lifetime, how many online classes have you taken? Including this one. Okay, all right, so now I'm going to have to go up. 25, wow. Okay, so what just happened? I'm in the chat and there's all this blank, weird stuff. Okay, just a minute. Okay, so Chase has a 4. So I'm just going to type in the numbers. And the good thing about the spreadsheet is you don't have to do anything other than type in the numbers. And then 26671. Let me keep going. 8713. I think, unless that was some other question. Oh, no, that was another question. Sorry. I'm on the wrong part of the chat. Ah, we got different numbers. 3. There we go. Sorry about that. One more time. Okay, we got 3310. I don't think I can make this bigger, so sorry if it's going a little slow. 215. Why is there all this white space? Here we go. 72537. I think that's a record for me. 25 classes. I haven't seen that before. That's a lot. 43. Okay, so by the way, this is a sample. We could look at it as a sample of the whole class. There are 11, and there's something like 60 of you in the class. We could also look at this at the census if you thought of this as a survey of those who are online right now. So again, a lot of it is perspective. Is that clear? If we think of it as a sample, then all these numbers like the minimum, mean, sample variance, all that kind of stuff, those are called statistics. Must be an important word because that's the name of the class. So those are statistics. So for example, the minimum is a statistic. The mean is a statistic, 7.45, etc. Okay, so I want to go through some of these statistics. If you think of it as a census, as the whole population, we call these parameters. I hope you all know what the word minimum means. Am I okay with that? Tell me no if you don't, but hopefully you do. What the mean is a fancier word. What's a simpler word for mean that everybody knows? Y'all know a simple word. You may not know what mean means. Average. Average. So the mean is the statistics word for average. So I want you to use the word mean instead of average in this class. Okay. Sample standard deviation. That's really important. That tells you how spread out the data is. So what we can kind of say is the mean was 7.45 or so. And we can say not everyone, of course, is at 7.45. Nobody's 7.45. But the average student is about 7.019 away from 7.45. Any questions on that? So the sample standard deviation talks about how spread out the data is. And that is the most important new statistic for these first few weeks. So get that one down. If you have any questions, let me know. The formula is a little intense, so I'm not going to go over it. You need to know how to either put it in a spreadsheet. It's very easy in a spreadsheet. You just type it in and look. Or you can look in the calculator, and there's a video on how to do that. Okay, so you're confused by this. So it tells you how spread out the data is. So another way of looking at it is, see this histogram? Notice that the data is pretty spread out. I mean, there's a number at 25. There is a number at 2. It's all over the place. How spread out is it? On average, it's about 7 away from the mean. Okay, so I'm going to call it an average and not the average. I know that sounds weird, but I need to be, so that I don't, especially since I'm being recorded. So it's kind of an average distance away from the mean for all of the data points. Does that help a little bit? If the data is very spread out, not each point is that much away from the mean, but if you look, none of the points are exactly 7.019 away from the mean. But one might be, say, 6.019, and the other might be 8.019, and the average of those would be 7.019. So it's the average distance from the mean, or an average distance from the mean, not the distance of each value, but it's an average distance from the mean. So if you have a very high standard deviation, then that means everything's very spread out. If you have a very low standard deviation, that means there's not much spread. So for example, let's suppose, I'm going to give you another example. Let's suppose the data instead was the midterm score. If I told you the average midterm score was 80%, what do you think? Do you think that was really good or not? And my goal is to get everyone to pass. And the answer is I haven't given you enough information. If I told you the average was 80% and the standard deviation was 1%, then we have amazing success. Because pretty much everyone passed the class. Because if you were at below 70%, that means you're more than 10 standard deviations away from the mean. Okay? Which is very hard to beat. It's pretty much impossible. Okay, on the other hand, if I told you the average is 80, but the standard deviation was 10, then there's going to be a lot of people that are below 70. Do you see that? Then most people are doing really poor or getting A's. And that's not what I'm hoping for. I'm hoping that everyone passes. Yeah, so if the standard deviation is really small, like 1, then you would say that most people are really close to the mean. If the standard deviation is large, you would say most people are far from the mean. Any questions on that? Okay, the median is that you learned in 5th grade, and you remember? Of course, it's been a while for most of you. I did have a 16-year-old in my face-to-face class today. She remembered. And remember what median means? It's been a while. Yeah, it's basically the number in the middle. So you organize the numbers. Okay, you sort them. And then if there's an odd number of numbers, you pick the middle one. If there's an even, you take the average of the two middles. Oh, you made a song. That's kind of cool. By the way, if I started singing, you'd all log off. Because that is not my talent. So I'm not going to sing. Okay, I have my talents, and that's not one of them. Okay, so yeah, so it's again, it's kind of the middle. The mean and the median are different. If you have symmetric data, they're the same, but often you don't. So let me give you an example. If you look at income in America, then the mean is much higher than the median. Because, as you probably know, there are those people that are the billionaires, right? Okay, and then there's everybody else. And what happens is that if you look at the median, there's a few billionaires out there, but the middle is going to be like everyone else. Do you see that? But if you take the average or the mean, then those billionaires are going to skew the numbers upward. Does that make sense to everyone? The other one you'll hear the median a lot because people are more interested is home prices. And it's just like income. So you have those houses on the mansions on the lake, you know, the $50 million houses, and we have them in our town. I don't know if you have them in your town. And that, so if you look at the median home price, that'll give you more like what a typical resident lives in. If you get the mean, that you lose your typicalness. Why would you want the mean? Who would be more interested in the mean than the median? There are some people for home prices, for example. Here's a hint. I was friends with them and I was in politics. The richer class? Oh, not necessarily, actually. Not quite. Okay, city council. Because they care about taxes. And you get that $50 million house that's taxed at 1%, and that's bringing in a whole lot of money in to the city taxes. So the median is not very helpful to understand how much tax revenue is coming in into your town. You need the mean. Because if you take 1% of the mean, then that's going to be the tax revenue from housing, from houses. Okay? It's a little more complicated than that with Prop 13, but let's pretend there's no Prop 13. So you take 1% of that, and so the mean is going to tell you more how much tax revenue is coming in. So again, it depends on what you're interested in, whether you want mean or median. We're going to spend more time on the mean in this class than the median. Part of that is because it's easier. If you take an advanced stats class, you'll start learning about the median. But we're not doing that. Maximum, I hope you all know what that is. Highest one. Okay. Q3. Q3 stands for third quartile. And what that means is that if you order everyone, then you know the median's in the middle. So if you look at the top half, it's basically the median of the top half. And that's the third quartile, also called the 75th percentile. Okay, N is the sample size. There were 11 people that answered the survey. Q1 is the first quartile. So that's very similar to the third quartile, but instead of taking the median of the top half, any guess on what you can do? For Q1? Yeah, you take the median of the bottom half. So what we often say is we have the 5-point summary, or the 5-number summary. The minimum, the first quartile, the median, the third quartile, and the maximum. And that cuts the population into 4 pieces. Any questions on that? Okay, like your grades show on the, yeah. So I think on Canvas, I actually don't know what your grades show because I'm not a student, so I don't get to see it. But I believe you that the grades are showing the quartiles. So that's what it means. If it says quartiles, that's what it means. A lot of this stuff are later chapters. We're not touching it. We will get into this in a big way, by the way. This p-value is huge. We're spending weeks on this, but not today. Okay, so the z-score is also important. So this is one of my favorites. Okay, I got on my SAT score a 1,470 score on my SAT when I took it. My daughter took the SAT, and she got 2,050. Can you tell me who did better? Yeah, the answer is you can't, okay? Unless you really know about my family, which you probably don't, okay? You can look at me and guess my age. You probably know very little about my daughter. But we took it at different times, so those numbers aren't meaningful. Do you see that? What's more meaningful is our z-scores. What the z-score is you take the mean, you take your number, subtract the mean, and divide by the standard deviation. And it measures how many standard deviations you are from the mean. And what it does is it tells you how special you are. And it could be special on the high side or the low side. Does that make sense? Okay, so my z-score was about 2.2. Okay, by the way, that's pretty good. Okay, my daughter's z-score, and she never let me live this one down, was 2.3. So now you can say who did better on the SAT. Yeah, she did. A little bit better. Okay, but I did a little better than her on math. My z-score was really high in math. You might guess that. Hers actually was really high also, but mine was even higher. She was very good at math. But the z-score will tell you how unusual something is. If you're at a z-score bigger than 2 or less than -2, we call it an outlier. Okay? And that means it's unusual. If you're at a z-score bigger than 3 or less than -3, then we call it an extreme outlier. And that means it's extraordinarily rare. Okay? Typically, less than 1% will be extreme outliers. Typically, around 5% will be regular outliers. Okay? That's about 0.3% to be extreme outliers typically. And we'll get into that in another chapter. So you don't have to memorize the numbers right now, but it is important. I want to mention that I'm not going over everything. We don't have that much time left. And so you are responsible for reading the chapters and watching the video because it has more details. I try to keep it short enough so you don't bail on me. Besides that, we're probably getting hungry for dinner. Okay, so it is important that there's a lot of other things you need to know. Chebyshev's theorem, for example. I'm going to let you read up on that, the empirical rule. So there's a lot of things that you need to know that I don't have time in the short amount of time I do in the webinar. So just let you know, but that's all in the book, for example. It's also on the videos. But I do want to mention the IQR. And the IQR stands for the interquartile range. And what that measures is the difference between the first quartile and the third quartile. So in this case, the interquartile range is 5.5. So what we can say is that if you look at the first quartile and the third quartile, they differ by 5.5 courses. Any questions on that? Okay, online courses, because that's what this data was. I think you know what the word mode means. Does everyone know what the word mode is? No, somebody forgot? Maybe that's because it's 4th grade. It's the most frequently occurring answer. So more people answered 3 than anything else. We're not going to worry about any of this other stuff. Standard error is really important, but we don't do that for another month. So just keep in mind that that's down there, but just keep it in the back of your head, not in the front of your head. Any questions on this? By the way, if we want a z-score, let's find the z-score for 25. So I type in 25. I hit enter, and it's 2.5 about. What can you say? Is it an outlier? Is 25 an outlier? Yes. Is it an extreme outlier? No, it's not, because it's more than 2, but not more than 3. Any questions on that? Let's look at the minimum. The minimum that somebody said was 2. And our z-score is negative 0.8 about. Notice that's a negative number, which means we're below the mean. Because remember, it's a number minus the mean, and that'll be a negative number when you subtract, divided by the standard deviation. Is that an outlier? Definitely not. Okay? It's not even close to negative 2. Do you see that? So there is an outlier. How about 15? I'm going to search for outliers. So I'm going to type in 15. Is that an outlier? No. So what we can say is that the only outlier for our data is 25. Because we know none of the others can be, because the others are all closer to the mean than either 2 or 15. So there's only one outlier, and it is 25. So it's not hard to find the outliers using this program, by the way. Notice I have changed this, because on your projects, don't use the number 15. That was for this example. Do you see that? So that's why I wrote change this, because so many people on projects could just use the number that was like the last one I typed in. And that tells me they don't really understand what's going on. So that's why I put the word change this. Any questions on this? Okay, just a note, here's a histogram. Notice that it has a mode on the low side, and it trails downward from that. Do y'all see that? We call that skewed right. So that means that it is high on the left and low on the right, and that's skewed right. If it's the mirror image, and if it was high on the right and low on the left, I bet you could all guess what you call that. Yeah, you call that skewed left. Okay, if it looks like a mound, sometimes they call that a bell. We call it normal. Okay? If it is flat, if all the bars are the same height, we call that uniform. Okay, so a lot of vocabulary today. Have you noticed that? Okay, it's all in the book. It's on the videos, so, but you are responsible for it. Okay, I want to show you a couple things. Here's some bad news. I was so pissed. Let's see. On mine, we'll see if it works. It may or may not. If we go ahead and go to stats, go to box plot. It may not let me do it. Let's see, how do I do it? Advanced, maybe? Go to Google Apps. Well, let me do it. By the way, I did not put a virus on it. It's warning you there might be a virus. I did not put a virus on this. I will not give you a virus on your computer. And I need to allow. Let's see if it does it. Please let me do it. There we go. Okay. So it's a lot of work to get there. I probably didn't used to do all this, and they did all security stuff. Sorry about that. This is a box plot. So do you remember I told you about the 5-number summary? The minimum, the first quartile, the median, the third quartile, and the maximum. This is a picture of the 5-number summary. And in particular, this red part, this middle part, that is the middle 50% of the data. So if you kind of want to know what the typical middle 50% is, box plots are really good for that. A couple downsides of box plots. One is that uneducated people have no idea what this is. Okay, so if you're presenting to an uneducated group, don't use a box plot. If you're presenting to an educated group, then you can assume they've had a statistics class and they know what a box plot. The interesting thing is that'll be different in 10 years. Any guess why? And maybe 20 years, depending who you're talking to. Common Core, have you heard of that? Box plots are now standard in the Common Core curriculum in California for middle school and high school. So all kids learn box plots. But my guess is you didn't when you were a kid. So now you're learning it. So anyhow, this is a box plot, and it's really good for telling you the middle half. But again, uneducated people don't understand it. The other problem is it only gives you what it gives you. So you're not going to be able to figure out the mean, for example, at all, or the standard deviation. But you can find the 5 numbers. Is that clear? Okay. The other thing, hopefully it'll let me do it. I don't have to go through all the hell. Okay. Okay. This is called a stem and leaf plot, or a stem and leaf diagram. Okay. Here's what this does. Okay. What it does is it breaks the numbers in to pieces by digits. So for example, this first number 2 is just 2. Below that, this 0 corresponds to 10, because you have the 1 and a 0. So you can get the shape. The good thing about a stem and leaf is that it's really good for being able to get the data back. You can get every individual data value back by looking at the stem and leaf. We know that there were exactly 2 people that said 7. Do you see that? Whereas if you look at the histogram, you can't know how many people said 7. We only know ranges. Do you see that? Okay. The problem with the stem and leaf is, one is, let's suppose we did this for SAT scores in America. Well, there's like millions of kids taking the SAT, right? It won't fit. You're not going to get 100 numbers, a million numbers on a little box like this. So it doesn't work for very large data sets. The other problem is if you're presenting it and you have number phobes, you know what that means? People who hate numbers. Okay, some of you might be in that category. Then they will look at this and they will hate you. Whereas histograms are boxes, not as scary. So that's the problem. And also you have to kind of know how to read it. Any questions on that? The bottom part, by the way, this is just if you are blind, then it will read it to you. So I made it so it's legally accessible and all that. So that's not really part of a stem and leaf. That's so that a blind person can be able to understand it. So really it's this part, this top part that you want to look at. Any questions on the stem and leaf, the histogram, or the box plot? The box plot is often sometimes called the box and whiskers plot because those two ends are whiskers. Okay, it's 7:25. So what have I not done yet, which I say I have to do? Yeah, secret word. So it's time. Okay, so can y'all see what I just did? I put a box. The secret word is, I know it is, but just make sure. Yep. You might be able to guess, although you might not guess perfect. So hard for me to draw this. I don't know what stuff I'm doing as a mouse. The secret word is statistic. Okay. By the way, not statistics, it's statistic. So for example, the mean is a statistic. So I try to make the secret word relevant to what the lecture was about. And a statistic is a really important thing in chapter 2. So what I'm going to do is I'm actually going to erase all of this. I'm going to unshare. Let me go over here. Grab. Okay, and I'm done saying what I need to say, but I'm always happy to answer questions. So if you have any questions about anything, I can go over whatever you want. And just like the orientation, if you don't have questions, say goodnight. We can have dinner or whatever, and we'll be done. But I'll stick around until either you're all out of the room or there's clearly no more questions. There's sometimes people that just like left without leaving the meeting. But if you have questions, I'll be happy to answer. And I'll probably mention the next webinar probably on Thursday. I'll let you know what day it is. If you have a suggestion, that's why I want to wait till Thursday, post on the Q&A. Again, Mondays and Tuesdays evenings usually work the best, but I can do other times. You say if you have our work turned in on Wednesday or Thursday, you'll look it over. What I said is on Wednesday, what I do is every day from now until Wednesday, which is only tomorrow, I'll look at the discussion posts. Okay, and help you. Okay, so if there's any problems with your discussion post, I'll look at it. Someone already posted earlier their link, and I liked it. So if I don't say anything, that's usually a good sign. Okay, so that's the answer to that one. So if you have questions and you can't answer now, post on the Q&A form. I'll be happy to answer them too. I'll be checking pretty much all day tomorrow, except not from 9 to 11 or 9 to 10:45-ish, because that's when I teach my calculus class. Okay, except Sierra, because she's in the class. So she could ask. Any questions? Okay, good night, Joy. And by the way, you're ready to do the secret word quiz. If you have any trouble with it, let me know, because I know you were here. So, but hopefully you don't. But don't forget to do it. Yes, that's for the attending orientation. So I have my list. So, Catherine Cravey, let me look. Next one. Oh, it didn't pop on this. Let me get on this list. For some reason it didn't print page 2. Oh, I know why. Front and back. There we go. I knew something was wrong. Catherine McCravey. Yep. Did you attend, Catherine? Let me see if I can find you on my didn't get the names. Chimed in later. Let me see. I might have put you on my other list that came in later. Let me see. Okay, now I have you. So let me double grab that. Okay. Other questions? Can you touch on the z-score one more time? Okay, so first thing, the z-score, let me put it in here. Z is equal to x minus mu over sigma. Because I'm using the chat box, I can't type Greek letters, but mu is a Greek letter. Kind of looks like a U with a tail. And all you remember is what's my favorite thing that has a tail, and what does it say? And what does it say? Okay, but actually the way she says it is mu. So that's the way to remember. Sigma is an O with a hat, is the way it looks in Greek. And mu is the mean, sigma is a standard deviation. So for example, if x is the mean, you get 0, right? Mu minus mu is 0. If x is far from the mean, the numerator is going to be big. Do you see that? But you're dividing by the standard deviation, so it's with respect. It's how far from the mean it is with respect to the standard deviation. If you look at that equation, Tammy, does that make sense? Okay, and it's a very easy formula, but you are responsible for it. You don't have to memorize it. You can put it on your little note sheet. But that's the one thing the calculator doesn't do. The spreadsheet does, but the calculator doesn't. Yeah, so z is how far from the mean with relation to standard deviation, and it's signed. So if it's negative, that means it's below the mean. If it's positive, it means it's above the mean.
So if the standard deviation is 1, and so you take x minus the mean, I'm trying to understand the relation between the answer that you get and then the standard deviation. I'm sorry.
Okay, let's do one that isn't 1 because 1 is too simple, actually. Because divided by 1 doesn't do anything.
Yeah, of course, yeah.
Okay, so let me give you an example. Let's suppose we have the mean. Let's do IQ, for example, because that one I know the mean. So the mean is 100 for IQ. Okay. And the standard deviation, maybe I should have written mu. Oh, you can't see it yet anyway. So mu equals 100. And the standard deviation is equal to 15. Okay?
Okay.
And just trust me on that. That's true for IQ stars.
Okay.
Okay. So now, somebody is classified as GATE. Have you heard of GATE before?
I'm sorry, no.
Gifted and talented education.
Yeah. Okay,
so,
yes.
Super bright. If their IQ is 130. Okay? 130 or higher is classified as GATE.
Okay.
So, what's their z-score? So if you're at the edge of GATE, what's your z-score? So if
130. 130 would be at the edge.
But what's the z-score? So the z-score, again, you put it in the formula. You go 130.
Minus the 100 is 100 the 30 divided by 15 is 2.
Divided by 15. Okay. And again, you're always allowed a calculator, but you must force the order of operations. If so you do 130 minus 100 divided by 15 in your calculator, it'll give you the wrong number. You need the parentheses.
So it'd be 2.
It'd be 2. So z equals 2. And not a coincidence that outliers are GATE students.
Of course.
And that's how they determine GATE. Okay, in the old way. Now it's more complicated. But the old way, that was how they determined GATE, is you had to be an outlier for IQ score. And you had to be an outlier on the high side, obviously.
The example helped. Thank you.
Good, good. Yeah, having an example, a concrete example helps a lot.
Okay, that's all for me.
Okay, great. Well, thanks, Tammy.
Thanks so much, guys.
Mohammed, any questions? Any questions? Again, I stick around until there's no question.
Yeah, thank you. No, actually, I need to read a lot, and some of these terms are new for me.
Oh yeah,
Totally.
none of this is supposed to be like review. You know, I mean, average. I think you've seen the average.
Yeah.
But
for me, it was more. Yeah.
Huh?
For me, it was a little more. Yeah.
Yeah. No, this is supposed to be all new.
Yeah. For me, I moved from Afghanistan, and then our school much different from here. And yeah, during my school, middle school, especially high school, was during the war, not really good with math.
I can't imagine Afghanistan having a good place to grow up in.
Yes.
Yeah, I think going to America was a really smart move on your part.
Yeah, we had a chance, but not many people.
I've never been to Afghanistan, but when I read the news, it doesn't sound safe.
Yes. Thank you. And my question was, for the book, how do I know from which from which page to which page should I read, and then
okay, well, first thing in the book, don't really if you go to the online book, there's no page numbers.
Okay,
there's only chapter and section numbers.
Okay,
so in fact, I can share and I'll go to the book, so that way you can see it. This one, I think. OpenStax. And let's go to it. So if you go view online.
Yes.
So if you go to contents, then this week we're doing chapter 1 and chapter 2. So you'll want to read each of the sections in chapter 1 and chapter 2. So section 1, section 2. So it's online, so there's no page number per se. Does that make sense?
Okay. Yes,
so read through, there's examples, you know, and the most important thing is you understand it and that you learn it.
Okay.
Okay. And I don't cover everything in the webinar, especially in these chapters, because they're not very intense. There's a lot of information, but there's nothing that's too confusing. Does that make sense? And I try to go over the highlights. So there's some things I didn't go into. Okay. Like I didn't go into frequency tables. They're not that hard. It's just a table, and you've done tables probably.
Okay. Yeah.
So they're the frequency table.
Okay. For the projects, how to select the group? The maximum was like 3 people to.
Right.
Okay.
So in discussions.
Okay.
And it's been very active, actually. In fact, in the discussion, Project 1 discussion, there's been 16 posts already.
Oh, okay. Okay. Yeah.
So
yeah, I didn't go there. Actually, I posted my 3 the other discussion about 2 right and 1 lie. Yeah, I did that.
Right, that you do also, but that's in a different discussion.
Yes.
This is where you want to find a partner. And you'll notice, for example, Miguel, this is the last class I need to graduate, really wants to find a partner, doesn't like to procrastinate, looking for a partner. So you could reply to Miguel and say, hey, you want to be a partner? Do you see?
Okay. Yeah.
That's how you
I live in Marysville, in Yuba, near Yuba City. I don't know if you have someone here to live.
You don't have to live near the person.
Okay.
You just have to be able to communicate online.
Okay.
Okay, this is an online class, so I don't expect any in-person communication. But I do expect you to be able to email each other or Skype or that kind of stuff.
Okay. Yeah.
But you might want to say, if you need to find someone in Marysville, there's probably no one in Marysville, but there might be someone in Sacramento, which isn't that far, right?
I come to work like 2 days a week in Sacramento.
Yeah. So you can say, hey, it'd be nice to have Sacramento, but it's not necessary. And you can't say it's necessary because it's an online class.
Okay, I understand.
Yeah.
Okay.
So, all right, strongly recommend don't say it's necessary. I have to find someone.
Okay.
That is right there. Okay.
Thank you so much. Thanks a lot. Yeah.
All right. Well, have a good night.
You too. Thank you.
And please post on the Q&A if you have questions and the discussion for, the project discussion for partners.
Okay. Okay. Thanks a lot. Yeah.
All right.
Good night.
Have a good one.
You too. Bye.
Bye. And for all of you who are watching this as an archive webinar, thanks for watching. Somewhere in here is a secret word. It'll be clear if you watch the whole webinar. So thank you for coming. Next week, well, there's a good chance we'll do it on Monday or Tuesday evening, but again, I'll take requests. And please post on the Q&A forum for any questions that are questions about statistics, and the project discussion forum to get project partners or to find out if you have questions about the project. So I look forward to working with all of you all quarter. So thank you very much.